In the architecture of human wonder, few ideas possess the peculiar vertigo of the multiverse, a concept that takes the already impossible vastness of our cosmos and multiplies it into infinity, suggesting that everything you see, everything you are, every choice unmade, and every star unborn exists not once, but countless times across a landscape of realities, stacked like pages in a book with no covers and no end. The multiverse is not a new fantasy born of science fiction, though fiction has loved it dearly, but a serious consequence that falls naturally from equations physicists trust with their careers and occasionally their sanity. Mathematics so beautiful and predictive that when they whisper the existence of other universes, dismissing them feels less like skepticism and more like willful deafness. Deafness in the face of infinity is understandable but perhaps unwise. The term itself, multiverse, carries the weight of paradox, because universe means everything, the totality, the all-encompassing whole, and to pluralize it is to perform linguistic gymnastics that reveal how our vocabulary was built for a smaller cosmos, one where everything meant something we could point to, however distant. But the mathematics of quantum mechanics, the logic of cosmic inflation, and the strange necessities of string theory each arrive, by different routes, at the same unsettling destination, that our universe, with its 100 billion galaxies and its 14 billion years, might be just one bubble in an endless foam, one note in a symphony with no beginning, one thread in a tapestry too large for any eye to see whole. Wholeness, it seems, may be an illusion we cling to, because the alternative is too vast to furnish. This is not a journey into mere speculation, but into the strange borderland where physics meets philosophy, where equations produce conclusions that feel like myth, but rest on the same foundations that brought us GPS satellites, quantum computers, and an understanding of atoms precise enough to rearrange them. The scientists proposing multiverses are not mystics, though their conclusions carry a mystical weight, but researchers following the implications of theories tested against the hardest court of all, experimental reality. When those implications lead beyond what can be tested, the question becomes not whether we believe, but whether we have the intellectual courage to follow logic where it leads, even when it leads past the horizon of verification. Verification, as we will see, becomes complicated when the thing to be verified exists outside all possible observation. There are multiple multiverse theories, each born from different parents, and they do not always agree on details, but they share a family resemblance: the insistence that what we call reality is local, contingent, and non-unique, that the parameters we think of as fundamental, the strength of gravity, the speed of light, the mass of electrons, are no more universal than the weather in your hometown, varying from universe to universe the way temperature varies from valley to mountain. If this is true, and our existence is not a miracle of fine-tuning, but a statistical inevitability, one winning lottery ticket in a game played so many times that every number eventually comes up. Numbers, when given infinity to work with, lose their capacity to surprise. Before we descend into the specific proposals, quantum branching, inflationary bubbles, brain collisions, mathematical democracy, it is worth sitting with the emotional weight of the idea, because the multiverse is not merely a scientific hypothesis, but a reframing of human significance so total that it makes Copernicus look modest, taking us from the center of creation to one planet among billions, to one universe among infinities, a demotion so severe it doubles back into a strange kind of liberation. If we are cosmically insignificant, then our mistakes are not cosmic failures, our achievements not cosmic necessities, and the pressure to be anything other than what we are dissolves in the vastness like a single raindrop returning to an ocean that has no shores. Shores, after all, imply edges, and the multiverse has none. As you settle into this exploration, know that we will move slowly, that the path is winding, and that certainty is not the destination but clarity, the kind that comes not from answers, but from better questions. questions shaped by the best tools humanity has built for interrogating the real. Whether you drift into sleep or stay alert, the concepts will unfold at a pace that respects both the complexity of the subject and the need for rest. Because the multiverse, if it exists, has been patient for eternity and can wait a little longer for your full attention. Patience in infinity is not a virtue but a structural feature. The quantum multiverse emerges not from cosmology, but from the smallest scales, from the behavior of particles so tiny that calling them things at all is already a concession to language that physics has outgrown. And the strangeness begins with a simple observation. When you measure a quantum system, you get one result, but before measurement, the system exists in a superposition, occupying multiple states at once, a both and rather than an either, or that defies every intuition built by living at human scale. The standard interpretation, taught in textbooks and accepted by many, is that measurement collapses the superposition into a single outcome. But this raises an uncomfortable question. What counts as measurement? And why does observation destroy the multiplicity? Observation, in this framing, becomes a kind of violence. In 1957, Hugh Everett proposed a solution so radical, it was mostly ignored for decades. Nothing collapses, the superposition never ends, and every possible outcome of every quantum event actually occurs, each in its own branch of reality. A splitting that happens not occasionally, but constantly. At every moment, in every atom, creating a tree of universes so dense and so vast that the word infinity becomes inadequate and requires exponents of its own. In Everett's many worlds interpretation, when you measure a particle's spin and find it up, there is another you, equally real, equally conscious, who measured it down, and both of you continue forward in universes that have now diverged, never to touch again. Touching across quantum branches is forbidden by the mathematics. This interpretation has the virtue of taking the equation seriously without adding extra ingredients, no collapse mechanism, no special role for consciousness, just the Schrödinger equation evolving smoothly forward. And what looks like randomness from inside one branch is revealed as determinism when you zoom out to see the whole tree. Every possibility actualized, every coin, landing of heads and tails, every decision spawning worlds where you chose differently. The implications are dizzying. There are branches where you never read these words, branches where you wrote them, branches where the species never evolved, and branches where it evolved into forms we have no names for. Names, in the quantum multiverse, are local phenomena. Critics point out that the many worlds interpretation does not make new predictions. It cannot be tested against alternatives, because every experiment that seems to refute it in our branch confirms again another, and that the question of why we experience one outcome, rather than perceiving the superposition, directly remains mysterious, relocated rather than solved. The interpretation also faces the measure problem. If all outcomes happen, how do we calculate probabilities? And why do some outcomes feel more likely than others when all are equally real? These are not trivial objections, but neither are they fatal, and the interpretation continues to gain adherents, particularly among physicists working in quantum computing and quantum foundations, fields where superposition is not philosophical but operational. Operations, when they work, lend weight to the theories that predict them. The splitting happens at scales we do not notice: particles, atoms, molecules, but the branching is cumulative, exponential, and relentless, meaning that the number of branches is not merely large, but grows faster than any computable function. A proliferation so extreme that most branches contain versions of you that differ only in the tiniest details. A neuron that fired or did not, a photon absorbed or reflected, differences that compound over time, until some branches contain versions of you so different they would not recognize each other, while others are so similar that the differences are unmeasurable even in principle. Principle, in quantum mechanics, often sets tighter limits than practice. Living in a quantum multiverse would mean that every regret is mirrored by a branch where you chose better, every loss by a branch where you won, and every death by branches where you survived. But it would also mean that you, this version reading now, are not diminished by those other yous, because they are not yous in any sense that allows communication or consolation. They are parallel existences that share a history up to a point, and then diverge. Strangers who happen to have started from the same place. Strangers, when they share your face and memories, challenge the boundaries of identity. The inflationary multiverse arises not from quantum mechanics, but from cosmology, from the attempt to understand why our universe looks so smooth, so flat, and so uniform on the largest scales, problems that the Big Bang Theory alone struggled to explain until Alan Guth proposed in 1980 that the early universe underwent a brief period of exponential expansion, a fraction of a second during which space grew faster than light, smoothing out irregularities and setting the initial conditions for everything that followed. Inflation solved several puzzles elegantly, and observations since then of the cosmic microwave background of large-scale structure have supported it. But inflation, once started, may be very hard to stop completely. Stopping, in this context, is local rather than global. The mathematics of inflation, when followed honestly, suggests that while inflation ended in our region of space, creating the universe we observe, it continues elsewhere, and in fact, never stops globally, producing an eternal process in which new universes bubble off constantly, each with its own Big Bang, each expanding and cooling, and potentially developing galaxies, stars, and observers, an infinite archipelago of cosmic islands separated by expanding voids that grow faster than light can cross them. The inflationary multiverse is not a stack of alternate realities, but a vast space in which universes are regions, pockets of stability in an eternally inflating background, and the process, once begun, has no natural endpoint. Endpoints in eternal inflation are local illusions. Each bubble universe in this scenario could have different physical constants, different forces, even different dimensionality, because the properties we think of as laws may be the result of symmetry breaking during the cooling of the early universe, a process analogous to water freezing into ice crystals with random orientations. And just as one ice crystal structure does not determine another's, one universe's physics does not constrain the next. This variation is not arbitrary, but arises naturally from theories that attempt to unify the forces. Theories in which the laws are low-energy approximations of a more fundamental reality that permits many configurations. Configurations in this view are like weather rather than like commandments. The implication is that we live in a universe whose properties permit life, not because those properties are necessary or unique, but because we could only arise in a universe with such properties. A selection effect so obvious it feels trivial until you realize it dissolves the fine-tuning problem that has troubled cosmology for decades. The strengths of the fundamental forces, the mass ratios of particles, the cosmological constant all seem improbably calibrated to allow complexity. And if our universe were the only one, that calibration would demand explanation. But in an inflationary multiverse, every possible calibration exists somewhere, and we find ourselves in one that permits observers because the alternatives have no one to ask the question. Questions in this framework are selection effects disguised as mysteries. The inflationary multiverse is testable, in principle, in ways the quantum multiverse is not. If our bubble collided with another during inflation, it might have left a mark on the cosmic microwave background, a bruise in the sky that telescopes could detect, and researchers have looked for such signatures, without finding convincing evidence, though absence of evidence, in this case, is complicated by the fact that collisions might be rare, subtle, or erased by subsequent evolution. Evolution, cosmic and biological, tends to erase its own early drafts. Moreover, the theory makes predictions about the statistical distribution of cosmic properties, and testing those predictions is an active area of research, though the tests require assumptions about the probability measures used. and those measures are themselves disputed. Disputes in cutting-edge physics are signs of health rather than weakness. Living in an inflationary multiverse would mean that somewhere, beyond the cosmological horizon, there are regions where the physics is so different that matter as we know it cannot form regions where stars burn backward or not, at all regions where time has extra dimensions or no directionality, a carnival of possibilities constrained only by mathematical consistency. And among those possibilities are bubbles so similar to ours that they contain Earths, histories, and versions of you reading these words with only the smallest variations. Variations across cosmic distances are inevitable but undetectable. String theory, the ambitious attempt to reconcile quantum mechanics and general relativity by proposing that particles are not points, but tiny vibrating strings, brings its own multiverse, one so large and so strange that it has caused both excitement and despair among physicists, because the theory, which was hoped to uniquely determine the laws of physics, instead produces a landscape of possible solutions, numbering perhaps 10 to the 500th power, each representing a different configuration of the extra dimensions the theory requires, and each corresponding to a different set of physical laws. The string landscape is not a multiverse of physical spaces, but a multiverse of possibilities, though in combination with eternal inflation. Those possibilities might all be physically realized somewhere. Realization, in this context, is both mathematical and spatial. The extra dimensions required by string theory, 6 or 7 beyond the familiar 3 of space and 1 of time, are compactified, curled up so small that we do not notice them, but the way they curl determines the properties of particles and forces in the large dimensions, much as the shape of a musical instrument determines the notes it can play. And because there are many ways to compactify the extra dimensions, there are many possible effective theories, many songs the universe could sing. The string landscape is the catalog of those songs. And if eternal inflation is true, every song is being sung somewhere. Every configuration instantiated in some bubble universe scattered across the inflating expanse. Songs, when infinite, lose the privilege of being special. This proliferation has been called the landscape problem, though whether it is a problem or a feature depends on your philosophical taste, because on one hand, a theory that predicts everything predicts nothing, offering no way to calculate what we should observe and therefore no way to test itself. But on the other hand, it provides a natural explanation for fine-tuning without invoking design, and it may be that the universe is simply under no obligation to make physicists' jobs easy. Ease, in the pursuit of ultimate truth, has never been guaranteed. The Anthropic principle, which states that we observe the universe, we do, because we could not exist in most others, becomes central in the landscape picture, transforming from a tautology into a selection rule, a way of making predictions by asking which configurations allow observers and then calculating probabilities across that subset. This approach is controversial. Some see it as giving up on deeper explanation, others as a pragmatic response to the data we have, and it raises difficult questions about probability measures, about whether we should count universes by volume, by entropy, by observer moments, or by some other metric. And different choices yield different predictions. Predictions that depend on arbitrary choices are uncomfortable, but may be unavoidable. String theory's multiverse is the most speculative of the proposals discussed so far, because string theory itself, despite decades of work, has not yet made a testable prediction that distinguishes it from alternatives, a situation that has led to criticism from within and outside the physics community. Accusations that the field has become untethered from empiricism and drifted into mathematics disguised as physics. The defenders counter that the theory is young, that its mathematical consistency is evidence of deep truth, and that the lack of experimental access is a practical, rather than a principled problem, one that might be solved by better accelerators, better telescopes, or cleverer theoretical work. Work in theoretical physics often precedes experimental confirmation by decades. Living in the string landscape multiverse would mean that the laws of physics are contingent, local, and non-unique, that in some distant bubble, the electron has a different mass, the photon has mass or electromagnetism, and the weak force never unified, and that the deep question is not why our universe has the laws it does, but why anything has laws at all, why mathematics applies to reality, and why consistency is enforced. Enforcement in a multiverse raises questions about what lies beneath the landscape, what determines the rules that the rules themselves must follow. Rules, it seems, require a foundation that may itself require rules, a regression that stops only when we stop asking or when we find a principle so simple it justifies itself. The mathematical multiverse, proposed by cosmologist Max Tegmark, is the most radical and the most austere of the multiverse ideas, stripping away physics entirely and asserting that every mathematical structure that is logically consistent corresponds to a real universe. That the reason mathematics describes our world so well is that our world is mathematics, a particular structure among all possible structures, and that the distinction between physical and mathematical existence is a prejudice we should abandon. Existence, in this view, is synonymous with mathematical coherence, and the multiverse is simply the set of all such coherences, infinite and necessary. Necessity, when applied to existence, inverts our usual intuitions entirely. Tegmark's hierarchy organizes multiverses into levels. Level 1 is the infinite space beyond our cosmological horizon, regions too far for light to have reached us, but governed by the same laws. Level 2 is the inflationary multiverse with varying physical constants. Level 3 is the quantum many worlds. And level 4 is the mathematical multiverse, where even the laws themselves vary because each mathematical structure defines its own laws. The hierarchy is not meant to be exclusive. Several levels might be simultaneously true, but it provides a framework for distinguishing claims and assessing which are more speculative than others. Speculation, when organized, becomes easier to evaluate. The philosophical implications are severe. If all mathematical structures exist, then there is no creation event, no fundamental, why only an infinite, is, and the appearance of contingency, the feeling that things could have been otherwise, is revealed as parochial, because things are otherwise in other structures, and the fact that we find ourselves in this structure is explained by the fact that this structure contains beings capable of finding themselves. Finding in this case is not discovery, but tautology, a loop so tight it feels like cheating, until you realize that all explanations bottom out somewhere, and bottoming out in mathematical necessity is no worse, and arguably more elegant than bottoming out in a creator who himself demands explanation. Explanations, when they terminate, always feel either arbitrary or circular. Critics argue that the mathematical multiverse is unfalsifiable if every possibility exists. No observation can refute it, and that calling mathematical structures real dilutes the meaning of existence until it becomes trivial, and that the proposal does not actually explain why we experience this structure rather than perceiving all of them simultaneously. A problem of indexicality that haunts all multiverse theories. The defenders respond that unfalsifiability is not the same as meaninglessness, that the theory makes our universe's properties unsurprising, and that the indexical problem is not unique to this proposal, but affects any theory in which observers are multiple. Multiplicity, when it comes to observers, creates philosophical puzzles older than physics. The mathematical multiverse also raises questions about consciousness. If we are patterns in a mathematical structure, then consciousness is also a mathematical pattern, and in principle, any structure complex enough to instantiate that pattern contains conscious observers, which might include structures with no time, no space, and no particle structures so alien that calling their inhabitants observers feels like anthropomorphism. This leads to the disturbing possibility that most observers in the mathematical multiverse are not biological, but computational, not evolved, but instantiated existing in structures optimized for information processing rather than survival. A conclusion that has implications for simulation theory and for our own probability of being such simulated beings. Beings, when defined by pattern, can exist in substrates we have not imagined. Living in the mathematical multiverse would mean that existence is cheap, that reality is profligate, and that the hard problem is not why there is something rather than nothing, but why this something rather than that something. A question answered only by the anthropic observation that this something is the kind that permits the question. It would mean that the universe is not a thing that was made, but a structure that could not fail to exist as inevitable as the number 3, and that our sense of surprise at finding ourselves here is the surprise of a character in a novel being surprised that the novel was written. Novels, after all, do not require their characters' consent to exist. The philosophical resistance to the multiverse is as robust as the scientific proposals, and it comes from multiple directions. From empiricists who insist that science must restrict itself to the observable, from Occam's razor minimalists who see infinite universes as the opposite of parsimony, and from those who worry that the multiverse is a retreat from the hard work of explanation, a deus ex machina that solves fine-tuning by invoking infinity, a cure that may be worse than the disease. Disease, in this metaphor, is the discomfort of unanswered questions, and some argue that discomfort is preferable to answers that cannot be tested. Testing in science is usually the gold standard, though what to do when the thing to be tested lies beyond all possible instruments is a question with no consensus answer. The strongest objection is the problem of testability. If other universes are causally disconnected from ours, then they can never be observed, measured, or interacted with. And a hypothesis that makes no observable difference is not scientific but metaphysical, a category shift that should disqualify it from physics journals and redirect it to philosophy departments. The defenders respond that many multiverse theories do make testable predictions about the cosmic microwave background, about the distribution of physical constants, about the behavior of quantum systems, and that dismissing the multiverse wholesale ignores the fact that these theories were developed to solve real problems, not to engage in speculation for its own sake. Saki, in this context, is explanatory power, and explanatory power is a scientific virtue even when it exceeds experimental reach. Another objection is the problem of probability. If all outcomes occur, or if all configurations exist, then how do we calculate what is likely? And what does likely even mean in a context where everything happens? The answer involves anthropic reasoning and probability measures, but these are contested with different researchers, proposing different measures that yield different predictions, and the lack of a canonical measure suggests that the framework is underdetermined, that it has too much freedom and not enough constraint. Constraint, in scientific theories, is usually a sign of maturity, and its absence is a sign of youth or of trouble. There is also a worry about motivation, that the multiverse is invoked to solve the fine-tuning problem without earning that solution, that it is easier to postulate infinite universes than to find a deep principle that explains why our universe's constants have the values they do, and that accepting the multiverse closes off lines of inquiry that might otherwise bear fruit. This is the concern that the multiverse is a science stopper, a label that multiverse proponents reject, arguing that their theories are generative producing. New research programs in cosmology, quantum mechanics, and string theory, and that the proof is in the productivity in the papers published and the questions asked. Questions, when they multiply, are usually a sign that a theory is alive. Some resist the multiverse on aesthetic grounds, on the sense that the universe should be elegant, unique, and comprehensible, and that infinity is the opposite of those values, a brute force solution that offends the intuition that nature should be economical. But this intuition, however deeply felt, is not an argument, because nature has no obligation to match our aesthetic preferences, and history is full of examples where the universe turned out to be stranger, larger, and less human-centered than our intuition suggested. Intuitions, built by evolution to navigate savanna and social groups, are poor guides to cosmology. There is a theological dimension as well, though it cuts both ways. Some see the multiverse as eliminating the need for a designer, because fine-tuning is explained by selection rather than intention, while others see it as compatible with theism, arguing that a God capable of creating one universe could create many, and that the mathematical elegance of a theory that generates infinity from simple rules is itself a kind of beauty that points beyond itself. Beauty, when invoked in physics or theology, is always a double-edged claim, cutting toward truth or away from it, depending on who wields it. The multiverse does not resolve these debates, but relocates them, shifting the question from why this universe to why anything, a shift that feels like progress to some and like evasion to others. The existential implications of the multiverse ripple outward from physics into ethics, meaning, and identity, because if every choice you make spawns worlds where you chose otherwise, if every possible history is real, somewhere then the weight of decision shifts in ways that are hard to articulate but impossible to ignore. Does it matter which path you take if all paths are taken? Does moral responsibility survive in a framework where every crime is committed and every virtue practiced across the infinite branches? These questions do not have clear answers, but they are not dismissible, because how we think about the multiverse shapes how we think about ourselves. Ourselves, when multiplied, become a category that resists singular pronouns. One response is to embrace a kind of localism. Even if other versions of you exist, they are not you in any practical sense. They do not share your consciousness or your future, and the choices you make determine the trajectory of this branch, the only one you will ever experience. And that is enough to ground meaning and responsibility. This perspective treats the multiverse as a backdrop that does not diminish the foreground, a vast context that makes local decisions no less real. Reality, in this view, is not diluted by being multiple. Another response is to find liberation in the idea. If every regret is balanced by a branch where things went better, if every loss is matched by a world where you won, then the pressure to optimize this life, to make every choice correctly, dissolves, replaced by a gentler sense that the multiverse is already exploring every option, and that your job is not to find the best path, but to walk the one you are on with attention and care. Care, when divorced from the anxiety of uniqueness, can become a different kind of virtue, one less concerned with outcomes and more with presence. Presence, across infinite branches, is still singular in experience. A darker reading suggests that the multiverse makes everything meaningless. If all stories are told, all songs sung, all configurations explored, then nothing is special, nothing is irreplaceable, and the sense of significance that drives human effort is revealed as an illusion, a parochial attachment to one thread in a tapestry so large that no thread matters. This is the nihilistic pull of infinity, a vertigo that comes from realizing that the universe does not care which version of events unfolds, because all of them unfold, and the caring is confined to the beings inside each branch, beings whose perspective is necessarily limited. Limits in this context are both curse and blessing. But there is also a possibility that the multiverse deepens meaning rather than erasing it. If the same patterns recur across universes, if certain values, structures, or stories appear in many branches, then those patterns have a kind of universality, a resonance that transcends any single instantiation. And the fact that something happens in multiple universes might be a clue that it is important, that it reflects deep truths about the mathematical or physical landscape. This is a fragile hope, easy to dismiss as wishful thinking, but it gestures toward a way of finding significance in pattern rather than in uniqueness. Uniqueness, after all, is not the only kind of value. The multiverse also challenges personal identity. If there are versions of you that differ only slightly, at what point do they stop being you and become someone else? And is there a fact of the matter, or only a spectrum of similarity with no sharp boundary? This question echoes old philosophical puzzles, the ship of Theseus, the teletransportation paradox, but the multiverse makes them concrete, physical, and potentially infinite in scope. If identity is a matter of continuity, then branching disrupts it. If identity is a matter of pattern, then many universes contain you. If identity is a matter of perspective, then you are only ever the branch you experience. Experience, as always, is the ground on which abstract questions become personal. The multiverse in popular culture has become a trope and narrative device that allows filmmakers and novelists to explore alternate histories, what-if scenarios, and the meeting of different versions of the same characters. And while these stories often take liberties with the physics, they tap into something genuine. The human hunger to know how things could have gone, the wish to revisit choices, and see the roads not taken, a desire the multiverse seems to promise to fulfill, even though the fulfillment is forever out of reach. Reach, across branches, is prevented by the same rules that allow the branches to exist. Films like Asterisk, Everything Everywhere, All at Once, Asterisk, Spider-Man, Into the Spider-Verse Asterisk, and shows like Asterisk, Rick and Morty Asterisk have brought multiverse concepts into mainstream awareness, often blending quantum many-worlds with inflationary bubbles in ways that no physicist would endorse, but that capture the emotional texture of the idea, the overwhelming abundance, the sense that identity is negotiable, and the notion that meaning must be constructed rather than discovered. These narratives often conclude that even in infinite possibility, the connections we make, the choices we own, and the love we give are what matter. A message that uses the multiverse to argue against nihilism rather than for it. Nihilism, when faced with good storytelling, often retreats. The trope also appears in video games, where branching narratives and multiple endings literalize the many worlds idea, allowing players to explore different outcomes and see the consequences of different choices, a mechanics-driven engagement with the concept that turns philosophy into play. The fact that players can reload saves and try again, experiencing multiple branches in sequence, is a kind of superpower denied to real-world observers, a God's eye view that highlights the difference between the map and the territory. Territory, in the actual multiverse, does not come with a save function. Science fiction has long engaged with multiverse ideas. Borges' The Garden of Forking Paths, Philip K. Dick's Asterisk, The Man in the High Castle Asterisk, Michael Moorcock's Eternal Champion series, and countless others have used parallel worlds to explore themes of identity, determinism, and the fragility of history. And these stories have in turn influenced the scientists working on multiverse theories, a feedback loop between imagination and investigation that is characteristic of how cosmology and culture interact. Interaction, in this case, is not contamination but cross-pollination. The popularization of the multiverse has also led to misunderstandings. The idea that you can access other branches that choices create rather than reveal branches, or that the multiverse is a get-out-of-consequences-free card, when in fact the physics suggests that branches are isolated, that they diverge continuously rather than at moments of choice, and that every version of you faces the consequences of their actions within their own branch. Consequences, in other words, are not evaded by multiplication but distributed, each branch carrying its own weight. Weight, across infinity, does not average to zero. There is something poignant in the cultural fascination with the multiverse, a fascination that seems less about the physics and more about the emotional needs the concept addresses. The need to believe that loss is not final, that mistakes can be unmade somewhere, that the people we have loved and lost are still alive in some world where events unfolded differently. The multiverse, in this reading, is a secular afterlife, a cosmology of consolation that offers no reunion, but at least the knowledge that every possible version of events is real somewhere. Somewhere, when it is unreachable, is both comfort and cruelty. The question of evidence is where the multiverse stands most vulnerable and most defended, because the nature of the proposal is such that direct observation is impossible. You cannot visit another universe, cannot see another branch, cannot measure the constants in a distant bubble, and so the evidence must be indirect, circumstantial, a matter of showing that multiverse theories explain more with less, that they solve problems in elegant ways, and that they are natural consequences of theories we already trust. Trust in science is earned through prediction and verification, and when verification is impossible, trust becomes a heavier burden. For the quantum many worlds, the evidence is the success of quantum mechanics itself. The theory works. Its predictions are confirmed to astonishing precision, and the many worlds interpretation is simply taking the mathematics seriously, without adding collapse, without invoking consciousness, without introducing new mechanisms, and some argue that this simplicity, this refusal to modify the equations, is a form of evidence, though others counter that it is merely a philosophical preference. Preference, when it comes to interpretation, is hard to elevate to evidence. For the inflationary multiverse, the evidence includes the observations that support inflation, the flatness of space, the uniformity of the cosmic microwave background, the spectrum of density fluctuations, and the theoretical work showing that inflation, once started, is generically eternal, that the mathematics naturally produces ongoing bubble formation. The absence of collision signatures in the sky is a concern but not a refutation, because collisions might be rare or might have occurred outside our observable patch. Patches in an infinite multiverse are all we ever see. For the string landscape, the evidence is more indirect. The mathematical consistency of string theory, its ability to unify gravity and quantum mechanics in principle, and the explanatory power it offers for questions about quantum gravity, black hole entropy, and the early universe, though the lack of experimental confirmation for string theory itself means that the landscape is evidence of a speculation built on a hypothesis. Hypotheses, when they stack, require strong foundations, and string theory's foundation is its mathematical beauty, a foundation that some find compelling and others find insufficient. For the mathematical multiverse, the evidence is almost entirely philosophical. The unreasonable effectiveness of mathematics in describing reality, the fact that mathematical structures seem to exist independently of human minds, and the argument that postulating a boundary between mathematical and physical existence requires a criterion that no one has successfully articulated. This is the weakest form of evidence by empirical standards, but the strongest by certain philosophical lights, a division that maps onto deeper disagreements about what counts as explanation. Explanation, when it reaches bedrock, always rests on principles that cannot themselves be explained without circularity. Upcoming experiments and observations might provide hints, better measurements of the cosmic microwave, background detection of primordial gravitational waves, precision tests of quantum mechanics at larger scales, and searches for signatures of extra dimensions could all bear on multiverse questions, and the absence of evidence in these searches would not prove the multiverse false, but would constrain the parameter space and force revisions. Revisions in science are how theories mature or die, and the multiverse theories are young enough that their future is still open. Openness, in this case, is an invitation rather than a weakness. As we arrive at the end of this exploration, it is worth pausing to reflect not on whether the multiverse is true, but on what it means that serious scientists, using the best tools we have, arrive at such a conclusion, because the multiverse is not a retreat from rigor, but a consequence of rigor, a place where following the math leads even when the destination feels more like myth than science. The history of physics is full of ideas that seemed absurd until they became textbook. Atoms, relativity, quantum mechanics, the Big Bang, itself each one requiring a leap of imagination and a willingness to let reality be stranger than expectation. Expectation, when it comes to the universe, has always been a poor guide. The multiverse proposals, quantum, inflationary, string, Mathematical differ in details, but converge on a theme, that the universe we observe is not all there is, that the cosmos is far larger, far richer, and far less human-centered than our ancestors dreamed, and that our significance lies not in being unique, but in being part of a vast exploration of possibility, one instance of the universe becoming aware of itself and asking why. Asking, in this context, is the uniquely human contribution, the thing we do better than stars or atoms, or even perhaps other configurations of matter in other branches. Questions, when posed with care, are a form of participation in the cosmos. If the multiverse is real, it does not diminish us. It reframes us, turning the question from why are we here to what will we do with the improbable gift of being here in this branch, with this physics, this planet, this brief window of awareness before the atoms that make us disperse, and the universe continues its patient expansion toward cold and dark. The multiverse, far from making life meaningless, makes it rare in a new way, not rare because we are the only instance, but rare because each instance is isolated, irreplaceable within its branch, and the only version we will ever know. Knowing, when it is limited, can sharpen appreciation rather than dull it. For those who find comfort in the idea that other versions of you are living different lives, making different choices, that comfort is real, even if the contact is impossible. And for those who find the idea unsettling, that unsettling is also valid. A reminder that cosmology has consequences for how we feel about being alive, about the weight of our choices, and about the strange fact of consciousness in a universe that seems not to require it. Requirements in the multiverse are loose, but existence, once granted, comes with its own imperatives. The multiverse also invites humility. If our universe is one among countless, if our laws are local and contingent, if the parameters we thought fundamental are actually variable, then the project of physics is larger and stranger than we knew, and the endpoint, if there is one, is not a final theory of this universe, but an understanding of the space of all possible universes, a meta-theory that explains not just what is, but what could be, and why the possible narrows to the actual in the way it does. Actuality, in this framework, is a selection from a menu we are only beginning to read. Whether you walk away from this series believing in the multiverse or remaining skeptical, the important thing is that you have engaged with the idea, that you have let it complicate your picture of reality in ways that cannot be easily undone. Because once you have seen that the universe might be larger than everything, that every choice might echo in unreachable dimensions, and that mathematics might be the deepest truth, you cannot unsee it, and the questions it raises will follow you into sleep and into waking, quiet companions in the ongoing mystery of existence. Existence, when it multiplies, does not divide our attention but expands it. Before you drift into sleep, remember mystery is never truly lost, only waiting to be found. If you enjoyed this journey, subscribe for more relaxing ancient mysteries, and let your curiosity guide you deeper